Hello everyone, welcome to my YouTube channel. In today's class, we will discuss about RSA algorithm in the subject of Cryptography Network Security. What is the meaning of RSA algorithm? RSA is a public key encryption algorithm, was developed in 1977 and published in the year of 1978. Okay, RSA was developed by totally three scientists. These are Rivest, Shamir, and Adleman. Okay, with their name Rivest, Shamir, and Adleman. Okay, because of their names, they declared the algorithm name is RSA algorithm. Okay, RSA scheme was supreme as widely accepted and implemented approach to public key encryption. Okay, RSA is a block cipher. What is the meaning of block cipher first? A block cipher is nothing but the plain text is divided into number of subparts, and after encryption also we will get the same size of the cipher text message. Those that is called block cipher. RSA is a block cipher in which the plain text and cipher text integers between 0 to n minus 1. Okay, there is a range is 0 to n minus 1 for some n. Okay, for some n number. Okay, here encryption and decryption are encryptions or decryptions are following form period at the same time. Okay, here the what is the meaning of what is the plain text? A plain text is nothing but human readable format is called the plain text. Where we will denote the plain text with M. And what is the cipher text? Cipher text is the human unreadable format is called the cipher text. That was denoted by C. Here to convert cipher text to perform encryption. Encryption means what? Encryption means after encryption you get the cipher text. So cipher text C equals to M power E mod N. And the plain text to perform the decryption, the plain text means M. So M equals to C power D mod N. Okay, if you write, finally we will get M equals to M power ED mod N. Okay, here C is the cipher text. Don't confuse. M is the plain text and E is the public key. E is the public key and D is the private key. Okay, first of all, first point. Here I already told that if RSA is the public key encryption, RA is the asymmetric key encryption cryptography. What is the meaning of asymmetric? Asymmetric is nothing but here two keys for used for encryption and decryption. The two pairs of keys. What are the two pairs of keys? The first one is public key and second one is the private key. Okay, in asymmetric key encryptions, we will use the a pair of keys. First one is the public key for encryption, second one is the private key for decryption. Okay, if any algorithm, if you use the two keys for encryption and decryption, those algorithms are called asymmetric key cryptography or public key encryption algorithms. Okay, now see here both sender and receiver must know the values N and E. N and E. E means what? E is the public key. Here, if you are the sender, you should know the public key, and the receiver also know the public key, and the receiver only knows D value. What is the D value? Private key. Okay, here the sender also don't know the what is the secret key. Okay, what is the private key? The private key is known by the only the receiver. The public key encryption algorithm with public key of KU, we generally will write the KU. KU is the public key. With what is the public key here? E comma and what is the E? E is nothing but public key, comma N is the product of the value. Okay, we will see what is the N value in upcoming in this video only after 2-3 minutes. Okay, and what about the private key? Private key is KR equals to D comma and again what is the meaning of D? D is nothing but private key and N value we will see here. Okay, next in RSA algorithm contains majorly 3 steps. In RSA algorithm we have majorly 3 steps. What are the 3 steps means? The first one is key generation, second one is encryption and third one is the decryption. Okay, first one is key generation, encryption, decryption. We will see what is the key generation. Here, in key generation, we have to follow some steps. What are the first step? In key generation, we have to follow some steps. The first step is we have to take we have to take or we have to select two prime numbers. Okay, we will mention that two prime numbers are P and Q. And then second step is calculate the product of n. Okay, before that in the public and private key we seen what is the n value. The product of two prime numbers is n, that is the P into Q. And the third step is we have to, in third step, which is the modulo for encryption and decryption. Next, we pi of n referred to as Euler coefficient value of n. Okay, there is a Euler coefficient value, but according to our syllabus, we don't have that one. What is it? To have to calculate the pi of n, or what is the formula for pi of n here? Pi of n value is p minus 1 into q minus 1. According to key generation, the pi of n value is p minus 1 into q minus 1, p minus 1 into q minus 1. Okay, what is the fourth step? Select an integer e. Here we have to select an integer b that is relatively to prime to pi of n. Okay, that means the greater common division of e and pi of n is 1. Okay, so the range is 1 less than e less than pi of n. Here what is the pi of n value? The pi of n value is 187. If you perform, sorry, what is the pi of n value? We will see in the example. Okay, next, what is the next step is to calculate d as multiplicative inverse of e modulo psi of n. So what is the formula here? D is x into pi of n by e plus 1. Here the d is, we can also write like this, d is e inverse modulo of pi of n. Okay, and what is the public key? Next step is we have to develop the public key. Public key is ku equals to e comma and private key kr equals to d comma and. Okay, this is about the key generation. This is the first step is key generation. What is the second step? To perform the encryption algorithm, and third step is to perform the decryption algorithm. Okay, see here, to perform encryption algorithm, to calculate the encryption, the formula is C equals to m power e mod n. C equals to m power e mod n. And what about the decryption? Decryption is m equals to c power d m mod n. Okay, we can also write like this. And what is the example? Okay, here this is the first step, key generation. Second step is the key encryption, and third step is the decryption. Now we will see one example for this RSA algorithm. Okay, example. In this example, I am taking example. Here, what is the first step? The first step is begin two prime numbers p and q. So I am taking first one, prime number p equals to 17 and q equals to 11. Okay, I am selecting two prime numbers. What is the next step? Calculate the product of n. So for product of n, so p equals to, what is the n value? N equals to p into q. So what is the value? 17 into 11. If we calculate, we will get, how much we will get? We will get 187. The second step is 187. And what is the third step? Calculate pi of n, that equals to p minus 1 into q minus 1. So the third step is pi of n equals to p minus 1 into q minus 1. So what is the value? 17 minus 1 into 11 minus 1. So we will get 16 into 10. So what is the value? 160. Here we are getting n value is 187. Here we are getting 160. Okay. And what is the fourth step? In the fourth step, select an integer e relatively q of n. That means greatest common divisor value of e and phi of n. So we have to check e value and phi of n value. What is the greatest value here? E means what? E means what? E is nothing but, what is the e value? E is nothing but public key. We have to check with public key and with phi of n value. So what is the phi of n value are getting here? 160. So in the fourth step, we have to calculate the GCD of 160 comma first one is 11. Okay, it means if you calculate this one, the remainder is 6. So it is a not prime number. Okay, if it is prime number only, we'll consider it is not a prime number. Okay, so here what is the formula we are taking? We are taking the formula is GCD of phi of n comma e that equals to 1. This condition has to be satisfied. Okay, it is not possible. And next one, GCD of 160 comma 17. If you perform this, remainder is 7. Remainder is 7. So it is what? It is the prime number. The 7 is the prime number. So it is accepted. So E value equals to 7. So according to this, E value equals to 7. What is the next fifth step? Fifth step is calculate D value. What is the formula here? D equals to x into phi of n by E plus 1. So fifth one is, if you calculate D equals to demand 160, that equals to 1. So here D equals to x into D equals to x into psi of n by E plus 1. That is the formula. Here where x we have to check with 1, 2, 3. We have to check the x value. Okay, which is divisible by 1. Okay, the result has to, what is the result we are getting? That is should be divisible by 1, 2, 3. Okay, then I have to check that, the value x is either 1, 2, 3. You have to check which value is the divisible. Okay, next here I am checking 1 into 160 by 7. E value is 7. So plus 1. Okay, that means 160 by 7 plus 1. Okay, here we are taking 7 into 160. What is the value? 22. So here divisible. So it is the x equals to 1 is correct. Okay, we are considering x equals to 1. So 22 plus 1 is 23. So what is the D value? D equals to 23. What is the D value? D is the secret key. D is the secret key. See here what we see. D is the private key. D is the private key known by the only receiver. And what is the sixth step? The sixth step is we have to generate the public key. Public key KU equals to E comma. Next, public key KU equals to E comma n. What is the E comma n value? E is 7, n value is 187. Okay, next, what is the private key we have to consider? Private key KR equals to D comma n. What is the D value here? D value is 23 comma n value is 172. Okay, according to this public key and private key, we have to perform the RSA algorithm. Okay, here I am taking one more example to show you. This is the RSA example. Here I am taking the plain text is 88 and the plain text, initially we are taking the plain text is 88 and it goes into encryption algorithm. What is the encryption formula here? C equals to m power e mod n. Okay, I am implementing the values here. What is the C equals to m power n? What is the m value here? M value is plain text is 88. So plain text is 88. So m means 88. E value is 7. So mod 7 mod and n value is 187. So here this is the formula we are implementing like this. If you calculate 8 power 7 mod 187 equals to the result is 11. Okay, it means what? The plain text is 88 is converted as 11 and the 11 is transferred over the network, okay, over the network the 11 value is transferred. Okay, so what is the original data is 88, that is converted as 11, and receiver side to display the data, what I have to do, the data has to be displayed as the plain text. So here we are performing decryption algorithm. What is the decryption algorithm? M equals to C power D mod n. Here M value is what? M value is 88. So sorry, we have to get the 88. So what is the C value? C value is 11 and D value is 23. So 11 power 23 mod 87. M means 87. If we calculate this one, we will get the 88 M value. Okay, this is the encryption side, this is the decryption side. Okay, don't confuse here. Some textbooks they referred as the private public key as the KU. Some other textbooks they given as the PU. Okay, both are same. Okay, here also KR and PR. Okay, it is the public key, it is the private key. Okay, when you are writing this exam, please carry your calcs because we have to calculate these lengthy values to get the proper results. Okay, thank you. Okay, this is about the RSA algorithm. What is the algorithm? The RSA algorithm means it is the asymmetric key public key. It is the asymmetric key encryption algorithm, or it is the public key encryption algorithm. What is the asymmetric or public key means? Here we will use the two keys for encryption and decryption. Okay, these type of algorithms are called public key encryption cryptography or asymmetric key cryptography. Okay, it is the very important question in the semester exams. RSA algorithm. Don't confuse here. If you have any doubts, please ask me in comment section. Thank you everyone.
నా ఛానల్ పేరు గుర్తుందిగా, ప్లీజ్ లైక్, షేర్ అండ్ సబ్స్క్రైబ్.